All right, guys. So we're talking about limits. We're moving along, and so there's this is limits of trig functions. Okay, so we have the limit. We have three ideas of how we work with the limits on this. So as we look here, we have our sign limit here. This is a sign limit also, and then this one here. Now you can put as I work on this, oops, let's see, it's not working here. Control Z, there it is. Uh, you can put any value in here, X or X, and this one can be X, and this one can be X, and this one's X. So so if we just did the basic one, sine of X over X, and so the idea is as the limit of X, the limit as X approaches 0 of sine of X over X is 1. So if we go to 0 from both sides right here, guys, my answer is going to be 1. Okay? So why is that really important? Well, here's the thing. This isn't just for the sine of X and the sine of X over X. It can be the sine of 5X over 5X. Okay? So this right here will also equal 1. It doesn't matter. That's why this box is here. As long as, let me erase some. Oops, it's supposed to be an eraser. As long as whatever is inside this box matches top and bottom. So if you notice, this box right here matches. So what's the limit as this sine of 5x over 5x approaches 0? It will also be 1. Same goes for this one here. This can be 5x over sine of 5x. And the only one that's different is this one with cosine. And again, this could be 7x and 7x. As long as what's inside or where the location of the box is the same, then these identities or these theorems apply. So they apply to anything that looks like this. All right? So our whole goal is to do this, is to create problems that will mimic this so it's equal to 1, so we can get our answer. So create a problem when we're dealing with sine that has a matching box up here and a matching box here, so it's equal to 1, so we can solve the problem. Same thing here, okay? These graphs, like I said, they're just to show you that this graph is going to approach 1. That's why the answer is 1. This graph coming from the left and from the right, it approaches 1. That's why the answer is 1. This graph coming from the left and coming from the right, it approaches 0. So how do we use these things? Well, we got 3 examples. Sometimes they get a little sticky, guys, so you got to hang in there, all right? So let's tackle a couple of things here. So if you look at this here, if you look at this, what happens is I got the sine of 3x over x, and I want the limit as that function approaches 0. Now look, if I draw a box around this and I draw a box around this, they don't match. So I need to add something. What do I need to add? I need to add a 3 down here in the denominator. So I have 3x, and then this will equal 1. So what happens is I multiply the top and the bottom by the missing piece, the denominator and the numerator. So when I multiply this times 3x, I get 3x. And then I have a leftover 3. So that leftover 3 moves out front. What do we know the limit as x approaches 0 of sine of 3x over 3x? It's 1. So I'll do a step right here. I get 3 times 1, so my answer is 3. So let's look at this. I've got this idea here. I draw a box around it. I put a 7 in front of it because I need a 7. That's my 7 right here. What I do to the bottom, I have to do to the numerator. So what I do to the denominator, I do to the numerator. That creates this 7x right here. So 7 times x creates my 7x in the box right here. I already have a 7x in the box right there. And so my question is, where does this extra 7 go? It moves out front because the limit of 1 minus cosine 7x over 7x is for this theorem right here. That is equal to 0. So since it's equal to 0, I get 7 times 0, which is 0. So there we go. Now, you guys are looking at this next one like, what the heck just happened? It went from nice and pretty to whoa. Okay, so if you notice in our theorems, we have sine, and cosine. There is no tangent theorem. So all of a sudden now, I have the tangent of 2x, and it's like, well, how do I tackle that? Tackle that a little differently. I tackle that like this. I have to change tangent into something. And so one of the trig functions is tangent is equal to sine over cosine. So if you don't know that, get used to it. You're going to see that a lot. So we know that tangent can be moved into sine and cosine. So right here, I change tangent into sine and cosine. So instead of tangent of 2x, I get the sine of 2x, cosine of 2x. So everybody's happy with that so far. Now I've got a fraction over the denominator. Now, here's a little trick. This is over 1, right? So what happens is this denominator flips and multiplies. Hi, Alina. You're a guest star anyways. No, you're good. There's no video. It's just me talking on my screen. There we go. No, you can say hi to Raylyn and Megan because they're probably watching this video. There you go. Alina says hi. So when I take the denominator and I clean it up, it's got to flip over and multiply. So if I do sine of 2x times 1, that's what this becomes. And then cosine of 2x times x becomes the denominator because I had to flip this denominator over. Remember, it's x over 1. That's how it kind of creates itself. So now I've got this piece right here. I don't necessarily so we got this all cleaned up right here, right? So this kind of looks confusing sometimes, so I'm going to kind of do a little different piece for you guys so you guys can see it. And so we know that tangent is sine over cosine, so I'm going to erase this over. So I'm going to do an extra little step in here. I like to separate things, and it doesn't matter how you separate it, but I like to use our fraction properties. So I'm really not going to look at this just yet. I'm going to wait for that piece. I'm going to take this, and I'm going to break it up still. So I know that I have the sine of 2x, right? Don't forget the limit as x approaches 0. I'm saving some space right there. You notice the limit as x approaches 0 is in every single step. Make sure it stays there. Okay? So the sine of 2x, and then I'm just going to put the x underneath it, times 1 over the cosine of 2x. Okay? So I just split this fraction up. All right, now, check this out. Here's my identity. What am I missing here to make this identity 1? So if I look at this, the box I need is missing something. It's missing a 2, and it's missing a 2. So now this becomes 1 right here. Right? That becomes 1, and I'm left with my 2 out front here, which is this step right there. They do it a little differently. but they end. I like to separate them out a little bit. So if I go 2 times 1, I get 2. If I go 2x times the cosine of 2x, I'm sorry, 1 times the cosine of 2x, I get my cosine of 2x. So I I don't know if you can kind of see the difference there. And then this becomes 1. So they do it a little differently and they split it out here. I like to split it out sooner. So this is just an extra step for you guys. If you don't want to write it, don't write it. But that's the way I like to do it. So now here's the fun part. I get the limit as x approaches 0 of 2 over cosine of 2x. I don't have a theorem for this, so what's my first thing I do with limits? Plug it in. So if I plug it in, I get 2 over the cosine of 2 times 0. So this is what I'm looking for. This becomes the cosine of 0, right? So now I've got to find out what is the value of the cosine at 0. This is where knowing, not your unit circle, it's very important, but I like this better. My cosine graph looks like this. Now, and then I've got 0, I've got pi over 2, I got pi, I got 3 pi over 2, and I have 2 pi. I want to know what is the value at cosine of 0. Right here at 0, my cosine starts at 1, right? So really this becomes, if I kind of slide it over here like this becomes 2 over 1 because the graph of cosine at 0 is 1. That's why it becomes 1. If we need help on our graphs and our cosine stuff, we can struggle with it. So we'll work on that. I'll help you guys work with that, and we'll get you set up. Okay, so now tomorrow, I got the notes set up for you guys. We're good to go. We are going to go over these 3 examples in class. So if you want to try them ahead of time to see if you can get the answer of 4 and 1/2 and 1/2, all those times, to go for it. But these are the 3 examples I'm going to start right after our opener tomorrow. Okay, guys? All right. Good job. We'll see you soon.